Here we have the infinite series with the expression n squared over n plus 1 factorial, and I'm going to use what's called the ratio test to show that this infinite series converges, and then to show that it converges to e minus 1. So let a sub n be the expression n squared over n plus 1 factorial. A sub n plus 1 is n plus 1 squared over n plus 2 factorial. The ratio a sub n plus 1 and a sub n will be this expression over this expression. N plus 1 squared is n squared plus 2n plus 1. And then n plus 2 factorial, we can rewrite it as n plus 2 times n plus 1 factorial. This factor n plus 1 factorial and this factor n plus 1 factorial, they will cancel each other out. So what's left is just the n squared plus 2n plus 1 over n plus 2 times n squared. And we get n to the third plus 2n squared. The limit of a sub n plus 1 over a sub n as n approaches infinity. It will be the limit of the expression n squared plus 2n plus 1 over n to the third plus 2n squared. Divide everything by n to the third. N squared divided by n to the third, we get 1 over n. 2n dividing by n to the third, we get 2 over n squared. 1 over n to the third, and then n to the third dividing by n to the third is just 1. 2n squared dividing by n to the third is 2 over n. As n approaches infinity, all of these terms up here, they all will approach 0. And then 2 over n also approaches 0. So for the whole thing, we get 0, which is less than 1. And therefore, the limit of the ratio a sub n plus 1 and a sub n as n approaches infinity is less than 1. And therefore, the series with the expression n squared over n plus 1 factorial converges by the ratio test. And now let's show that the series with n squared over n plus 1 factorial converges to e minus 1. Notice that n squared or over n plus 1 factorial, we can rewrite this as n squared minus 1 plus 1. And then n squared minus 1 is n plus 1 times n minus 1. And then we can split this up with n plus 1 times n minus 1 over n plus 1 times n factorial. And then what's left is just the 1 over n plus 1 factorial. And then the factors n plus 1 here, they cancel each other out. And then we get n minus 1 over n factorial plus 1 over n plus 1 factorial. And then this is n over n factorial, which is 1 over n minus 1 factorial, and then minus 1 over n factorial, and then plus 1 over n plus 1 factorial. And so for the series with n squared over n plus 1 factorial, we can rewrite it as the series with 1 over n minus 1 factorial minus 1 over n factorial plus 1 over n plus 1 factorial. And so here we get the first 9 terms, and then we can see that this term right here and that, they will cancel each other out, and then this one will cancel each other out. And then these two will cancel out with these two. And then these two will cancel out with these two. And then these two will cancel out with these two. And then we can see that these two and so we can see that what's left is 1 over 0 factorial, 1 over 2 factorial, 1 over 3 factorial, 1 over 4 factorial, 1 over 5 factorial, 1 over 6 factorial, 1 over 7 factorial, 1 over 8 factorial, 1 over 9 factorial, 1 over 10 factorial, 1 over 11 factorial. And then the next part over here will give us 1 over 12 factorial, 1 over 13 factorial. And so what we get is 1 plus 1 over 2 factorial, 1 plus 1 over 3 factorial, plus 1 over 4 factorial, and so on. And so what we have is the summation with n squared over n plus 1 factorial is 1 plus 1 over 2 factorial, plus 1 over 3 factorial, and so on. Power series for representation for e to the x is 1 plus x squared over 2 plus x to the third over 3 factorial, and so on. Let x be 1, we get e to the first is 1 plus 1 plus 1 over 2 factorial plus 1 over 3 factorial, and so on. And then subtract 1 from both sides. We get e minus 1 is equal to this sum right here. But this sum right here is the same as this series, the series that we're looking for. And therefore the summation with n squared over n plus 1 factorial is e minus 1. And that's the end of the video.